Section 7.1 is exploring exponential models. Our goal is to graph exponential functions showing intercepts and end behavior. On page 505, we have the number of moves needed for additional rings in the solvent suggests a pattern that approximates repeated multiplication. You can represent repeated multiplication with a function of the form y equals a times b to the x power, where b is a positive number other than 1. An exponential function is a function with the general form y equals ab to the x, where a is not 0, with b greater than 0 and b not equal to 1. In an exponential function, the base b is a constant. The exponent x is the independent variable, with domain the set of real numbers. Example 1 says, what is the graph of y equals 2 to the x power? To graph y equals 2 to the x power, we can make a table of values. Normally we don't have this many values, but to figure out the actual shape of an exponential function, we're going to use some extra values. So if we start with -4, we have y equals 2 to the -4. To make that negative exponent positive, we bring it down to the denominator, so 1 over 2 to the 4th, or 1 over 16, which is 0.0625. If we plug in -3, we get y equals 2 to the -3, which becomes 1 over 2 to the 3rd power, or 1 over 8, which is 0.125. If we plug in -2, we get 2 to the -2, which is 1 over 2 squared, or 1/4, and that's 0.25. -1 gives us 2 to the -1st, or 1/2, which is 0.5. If we plug in 0, we get 2 to the 0 power. Anything to the 0 power other than 0 is 1. If we plug in 1, we get 2 to the 1st, or 2. If we plug in 2, we get 2 squared, or 4. If we plug in 3, we get 2 cubed, or 8. Each of these points is plotted on the graph and color coordinated. So we have -4.0625, which is just very, very close to the x-axis. And then a little bit higher up, we would have -3.125. About a quarter of the way up, we'd have -2.25. Halfway, we have -1, 0.5. And then we have 0, 1, 1, 2, 2, 4, and 3, 8. The work for this problem is written out on the next slide. And now I would like you to try number 2, graph y equals 2 to the 2x power.